Not just one, but a whole bunch of black holes are hanging out together inside this globular cluster known as NGC 6397, and the Hubble telescope has given us a peek into that. For those that don't know, a black hole is a place in space where gravity pulls so much that nothing can escape. The gravity is so strong because matter has been squeezed into a tiny space. This can happen when a star is dying. Think of it as the universe's best kept secret. Whatever falls into a black hole stays in a black hole. The fascinating part, we can't directly see them. They're invisible. Scientists detect them by the effects they have on the space around them. Now, the globular cluster, NGC 6397, isn't just any collection of stars. It's one of the closest globular clusters to Earth, about 7,800 light years away in the constellation Ara. They are spherical collections of stars that orbit a galactic core, like satellites. Imagine a swarm of bees buzzing around, except each bee is a star and their hive is the Milky Way. NGC 6397 is particularly special because it's one of the oldest clusters known, with an age that's almost as old as the universe itself. It's like a living fossil, offering a glimpse into the past. The stars within are tightly packed, making it an excellent laboratory for studying stellar evolution and interactions. But what makes NGC 6397 stand out even more is its dark secret, something Hubble revealed to us not too long ago. This cluster isn't just a gathering of stars, it's also a hiding place for a surprising number of black holes. Because the cluster is relatively close to us, scientists were using Hubble to map the movements of stars within the cluster. Stars behaving oddly, as if tugged by an unseen force, hinted at the presence of these black holes. It was like seeing the invisible hand in a cosmic puppet show, revealing the black hole's hiding spots. This discovery is significant for a couple of reasons. First, it opens up new pathways for understanding how these black holes interact with their stellar neighbors and influence the evolution of clusters. Second, it suggests that the cores of globular clusters might be the resting places for numerous black holes, challenging our previous notions. Traditionally, astronomers believe that black holes within these clusters would be rare and not centrally located. The reasoning was simple. Over time, the gravitational push and pull between stars and black holes would result in the black holes being ejected from the cluster, leaving behind a black hole-less core. Moreover, it was assumed that if black holes did exist in globular clusters, they would either be solitary or found in very sparse numbers. This idea stemmed from the understanding that black holes, being incredibly massive, would quickly merge or eject each other due to their strong gravitational interactions. The discovery of the dense concentration of black holes in NGC 6397 leads us to an intriguing question. How did these black holes form and end up clustering together in the heart of the cluster? Firstly, it's important to understand that black holes in a globular cluster primarily form from the remnants of massive stars. These stars, much larger than our sun, live fast and die young. When they exhaust their nuclear fuel, their cores collapse under the force of gravity, leading to a supernova explosion. What's left after this cosmic spectacle is a black hole. But how do they end up at the cluster's core? The answer lies in a process called mass segregation. Over billions of years, the gravitational interactions among stars in the cluster cause heavier objects, like black holes, to migrate towards the center. It's akin to how in a shaken jar of mixed nuts, the larger nuts end up on top and the smaller ones filter down to the bottom. In the cosmic jar of NGC 6397, the heavier black holes settle at the core. This congregation isn't a static affair. Black holes in the cluster's core interact with each other and with nearby stars. Some black holes can merge, forming an even massive black hole, while others engage in dynamic dances that can eject stars from the cluster or pull them into orbits around the black hole. This concentration of black holes may also lead to more collisions and the formation of new stars or even more black holes. So in essence, the center of NGC 6397 has become a sort of black hole retirement home. It's a place where, after a long life of star shaking and light bending, these cosmic behemoths come to rest, influencing the fabric of the cluster around them. The concentration of black holes could also influence the way we detect gravitational waves. Collisions or mergers between black holes in such a dense environment could be a significant source of these ripples in space-time. This means globular clusters like NGC 6397 could be key targets for future gravitational wave observations, helping us to unlock more secrets of the universe. The revelation of a concentration of black holes in NGC 6397 opens exciting new horizons for space exploration and research. Here's a glimpse into what the future might hold. Firstly, this discovery underscores the importance of advancing our observational technologies. The Hubble Space Telescope, with its keen eye, has been instrumental in uncovering the secrets of the universe for over 3 decades. But projects like the James Webb Space Telescope, or JWST, promise to extend our vision further, potentially revealing more about the nature of black holes and the dynamics within globular clusters. Moreover, this finding could redefine targets for gravitational wave detectors like LIGO, Virgo, and future space-based detectors such as LISA, guiding them to look more closely at globular clusters as hotspots for gravitational wave events. Lastly, discoveries like this fuel our curiosity and drive for exploration. They remind us that the universe is a vast, complex, and wonderfully mysterious place.